A lot of this section is word problems, so if it's not on this page, you don't need to worry about it. I might change numbers like I did on the one on your quiz from whatever it was, 1.2. So just be aware of that, but overall, like, the general problem will be the same kind as what you have on here, be it one that we do together or one that you guys do for homework. So start with number 1, and in parentheses, I don't remember how I did it on the other worksheet, but I put the number that it is in the book, just for your reference. I don't think any of them have a picture that you need to reference in the book, but I could be wrong, so. Anyways, number 1, if a projectile is launched vertically upward from the ground with an initial velocity of 60 feet per second, neglecting air resistance, its height s in feet above the ground t seconds after projection is given by s equals negative 16t squared plus 60t. What equation can be used to determine the time at which the height of the projectile reaches 40 feet? So, t is time in seconds, and then the height s, so that tells us that I'm trying to determine what equation can be used to determine time as the height of the projectile reaches 40 feet. So I'm just going to take and plug in 40 for s, and so this would just be 40 equals negative 16t squared plus 60t. So these ones, you're just setting up what the equation would be. So in this case, they gave us the height. They wanted to know how long it would take, essentially, or at what height. So it's dealing with time. So we write it like that. If we go down here to number 3, though, it says, suppose that the quadratic equation s equals 0.0538 x squared minus 0.807 x plus 8.84 model sales of new cars, where s represents sales in millions. X equals 0 represents the year 2000. X equals 1 represents the year 2001, and so on. What equation should be used to determine the sales in 2010? So I'm trying to find an equation for 2010. If year 0 is year 2000, year 1 is year 2001, what year would 2010 be? Yep, 10. And so then I have this equation here. S is sales. X, we can tell, is clearly time. So when I'm plugging in, I'm going to plug in this number for x in this equation. So s equals 0.0538 times 10 squared minus 0.807 times 10 plus 8.84. And that's all you have to do on that one. Again, it was just what equation. We're not actually solving anything. Any questions on either of those two? All right, let's jump to the next page. We're gonna look at number 5. Oh, yep.
So is this part just like writing equations?
Getting into solving them. All right. A rectangle has an area that is numerically twice its perimeter. If the length is twice the width, what are the dimensions? So, in general, put this up here. A basic fundamental area formula, which would be like for a square, would be 2x squared. So we know that the length is twice the width. So the width I'm going to call x. The length I'm going to call 2x. What is the formula for perimeter of a rectangle?
2L times 2W plus 2W.
Yep, plus 2w. So if I plug in x and 2x here, I'm going to have 2 times 2x plus 2 times x, which is going to be 4x plus 2x. So that's going to be 6x. So the area is twice the perimeter. So I'm going to have area is equal to 2 times 6x. So this is related to perimeter. So that gives me 12x. So now this is my area. I have this fundamental area formula here. So I'm going to set these two things equal to each other. So I'm going to have 2x squared equals 12x. I'm going to subtract and get everything on one side. So 2x squared minus 12x equals 0. I'm going to factor stuff out, so take out a 2x. I'm left with x minus 6. And then using the zero product property, I can set each thing equal to 0. So 2x equals 0, x minus 6 equals 0. So I have x equals 0 or x equals 6. Now, is it possible to have a side length of 0? No. So this one is not possible. So my width is going to be 6 and my length is 2 times 6 or 12. All right, number 8. Grady is flying a kite on a 50 feet of string. Its vertical distance from his hand is 10 feet more than the horizontal distance from his hand. Assuming the string is being held 5 feet above the ground level, find the horizontal distance from Grady and its vertical distance from the ground. And there is a picture on page 131, so that one does have a picture. So we have our little dude over here. I'm going to draw a picture. Our dude standing here. He's holding a kite string. And this distance here is 5 feet off the ground. It says that the string is 50 feet long, so 50 feet here. The vertical distance, so that's up and down, is 10 feet more than the horizontal distance. So horizontal distance is going this way. So I'm going to call this x because I don't know what that is. Vertical distance is going to be x plus 10 since it's 10 feet more than that distance. So what shape do you see here that ends up being drawn? Yep, triangle, specifically a right triangle. So What do I know about right triangles?
Call it the hypothesis, like longest.
Yep, the hypotenuse is the longest side. If I have all these pieces, what special formula can I use to solve a right triangle?
A squared plus B squared equals C squared.
Yep, the Pythagorean theorem, a squared plus b squared equals c squared. So I'll call this side A, side B, and side C just for the sake of this problem. C always is the hypotenuse, but A and B, it doesn't matter which one. So I'm going to use this Pythagorean theorem to solve this. So I'm going to have x squared plus, in parentheses, x plus 10, because that goes as a unit and that's being squared, equals 50 squared. So I've got x squared plus, this is a special type, so this is going to factor into x squared plus 20x plus 100 equals this 2,500. So now I'm going to combine like terms and I'm going to move everything to one side for the purpose of me solving it out. I need to solve for x to find these distances. So I'm going to have 2x squared plus 20x. I'm going to subtract this, so minus 2,400 equals 0. Anyone notice anything I could do here now? Factor out of 2. So that'll make my life easier. So I can do that. And I'm going to end up getting x squared plus 10x minus 1,200. So I just wrote it this way. I factored the 2 out, and 0 divided by 2 is just 0. So the 2 is just gone. Now I can factor this. Any ideas? How about if I just wanted you to relate and say do factors of 12 that add up to give me, or I should say negative 12 that give me a positive 1? What would you do? 3 and 4, and which one would be negative, which one would be positive?
Negative 3.
Yep. 3 would be negative. Now, all I did is put 2 zeros on here. Any thoughts as to what I might need to do with these numbers?
Make it negative 30, 40.
Yep, negative 30 and 40. So I'm going to have, that's factors of that give me 10. So I have x squared, it doesn't really matter, minus 30x plus 40x minus 1,200. Factor by grouping, take out an x, I'm left with x minus 30. Over here, I'm going to take out a 40. I'm left with x minus 30. To come up here. So I have x plus 40 and x minus 30. I can use the zero product property, or zero factor property, whatever they called it. X plus 40 equals 0. X minus 30 equals 0. So x equals negative 40 or x equals 30. Now, what do we notice about this?
You can't have a negative side.
I can't have a negative side length, so that one's gone. I'm running out of room here, so I'm going to write it up here. So the horizontal distance, which is this value, is 30 feet. Now the vertical distance is a little different because I have 30 plus 10, but what else did I know?
Distance from the ground.
Distance from the ground, so I need to also add this 5 in for how far he is off the ground. So that's 5 there. So this is going to be 30 plus 10 plus 5 for a total of 45 feet. So that's what I'm looking for on one like that. Any questions on that one? All right, number 11, jumping a little bit. An astronaut on the moon throws a baseball upward. The astronaut is 6 feet 6 inches tall, and the initial velocity of the ball is 30 feet per second. The height S of the ball, so that tells me my height is going to be S, of the ball is given in feet by the equation S equals negative 2.7 t squared plus 30t plus 6.5, where t is the number of seconds after the ball was thrown. So, I've got this equation, and I guess I should read part A. Didn't get that far. After how many seconds is the ball 12 feet above the moon's surface round to the nearest hundredth? So, after how many seconds is the ball 12 feet above the surface? So, that's going to be my S value. Sorry, that is really blurry. I can rein it back in here. Hold on. Let me refocus it really fast. There we go. Okay. There we go. Okay. So, after how many seconds is the ball 12 feet above the moon's surface? 12 is going to be my S value, so I'm going to plug in 12 in that equation for S. So 12 equals negative 2.7 t squared plus 30t plus 60, or not 65, 6.5. So I'm going to subtract 12. I need everything on one side. So 0 equals negative 2.7 t squared plus 30t minus 5.5. Now, is this something I can factor? At least not easily, right? How about complete the square? Am I allowed to complete the square on this one?
Yes.
You weren't here yesterday, so you probably don't know. The answer is no. I cannot. Why can I not?
Because the entire problem isn't squared.
No, it doesn't matter about that. But what's this? A number other than 1. A number other than 1, so I can't complete the square. So what other method of solving might I need to use? It's the last big thing we did yesterday. Huh? That was the very first thing we did at 1.4.
Quadratic.
Quadratic formula. So, plug this in. Negative b, so negative 30. Plus or minus the square root of b squared, so 30 squared. Minus 4 times a is negative 2.7 times c is negative 5.5. Notice all the signs go with it. All over 2 times a is negative 2.7. And at this point, you're going to get two separate answers when you do this. So I would do it as like the positive one first, and I would go all the way through on your calculator and do that. For the sake of time, I already have the answer solved out, so I don't have to type it in. But I would say go back and make sure you type it in and get the answer that we get so that you know you're typing things in correctly. But when I do this, I'm going to end up with 0.19 seconds and 10.92 seconds. So when a like baseball or anything, whatever, is thrown or launched, what is going to be happening is essentially when it gets thrown, it goes like this. And so what this is saying is that at two separate times, the ball is at 12 feet above the moon's surface here. Okay, so this one is 0.19 and this one is 10.92 seconds for how long it takes, or like when it's that far above. How many seconds will it take for the ball to hit the moon's surface? So what height would it be above if it's on the moon's surface? How high is it? It's a trick question. It's on the moon's surface. How high above the surface is it? 0. So I do the same thing, except for instead of plugging in 12, I plug in 0. So 0 equals negative 2.7 t squared plus 30t plus 6.5. So this is the original equation. And here, this is s is equal to 0. So then I just set up the quadratic formula again. Negative 30 plus or minus the square root of 30 squared minus 4 times negative 2.7 times 6.5 all over 2 times negative 2.7. This one I did not check, so I need to do this one. So when I do the positive one, I get a negative 0.21 seconds. What's the problem with that?
You can't have negative seconds.
Right. No negative time allowed, so that one is automatically going to be a problem. The other one, when I do the negative one, so when I do this option, I get a time of 11.32 seconds. So it takes 11.32 seconds to get back to the surface once it's thrown. Any questions on that one? So notice at 10.92 seconds, the ball is 12 feet above the surface. Less than a second later, really what is that, 0.4 of a second later, it's at the surface. Things moving pretty fast. All right, next page, number 13. All right, salaries in millions of dollars for rookies selected in the first round of the NFL 2014 draft can be approximated by the quadratic model y equals 0.0258x squared minus 1.3x plus 23.3, where x represents draft pick order. Players selected earlier in the round have a higher salary than those selected later in the round. Use the model to estimate the salary of the player selected first overall to the nearest tenth of $1,000,000. So, I have this formula here that they've given me. X is draft pick order, and Y is the salary. I don't know if it explicitly says that, but use the model to estimate the salary of the player selected first overall. So, what number am I plugging in for X if that is the first overall draft pick? 1. So, plugging in 1 for X, I get Y equals 0.0258 times 1 squared minus 1.3 times 1 plus 23.3. And let's see, what do I get? 0.0258 minus 1.3 plus 23.3. This ends up coming out to be 22. It ends up being $0.0 million. So remember, it says it's in millions of dollars. So basically, the first round draft pick gets $22 million for their rookie contract. What is the estimated salary of the player selected 10th overall, round to the nearest millions of dollars? So, if they're the 10th overall pick, what am I plugging in for X? 10. So y equals 0.0258 times 10 squared minus 1.3 times 10 plus 23.3. And when I get that, I get y is equal to 12.9 million. So it's about a $9 million difference to be the first overall pick versus being the 10th overall pick. That is a lot of money. For a rookie. It's pretty crazy. Anyways. Alright, any questions on that one? Alright, there's not a ton of time left, so what I'm going to do is tomorrow is going to be a work day on this. And that way, if you have questions as you're doing something, you can come ask. Also, so if you want to start it right now, you probably get through like 1 or 2 problems because there's not that much time left. But we'll wrap this stuff up tomorrow, and then I can't remember if there's 1 or 2 sections left in this chapter. So we'll probably be having another quiz next week, and a test because I think the quarter ends next Friday, and I want to get another test in there. So just be prepared for that.